This lesson is going to set a very important foundation for a lot of the discussions we're going to have this year. You might look at this and see a bunch of definitions, but these are very, very important to understanding a lot of the concepts that you see throughout algebra. First of all, just to take something that looks very mathematical, 30n, to break it down, you should know by now that when there's no symbol in between, what this means is 30 times n. What we have here is we have what we call a term. We have something happening to the variable, and that something is called the coefficient. What a variable is a letter that represents a value that can change or vary. This word represents is going to be extremely important when you get to the actual use of algebra. And one thing that you're going to see is that this is extremely helpful when solving word problems, which is actually the real math, not doing simple equations like we're going to see in the video here, but the actual applying the algebra to real life. Coefficient is the number multiplied by the variable, but more importantly is understanding what that multiplication means. What that means is it tells us how many of the variable there are. Remember that multiplication is a simple way of remembering it. It's not the only definition, but it's repeated addition. So what this means is, this term here means that there are 30 n's. Whatever n is, whatever that represents, could be the number of hours you worked. So in that case, what this 30 times n would mean $30 for every hour you work. Important distinction to make here. You need to be extremely careful with the words you use. First of all, this is not an equation. This is not an equation. This is what we call an algebraic expression. It has one or more variables. Notice there's a difference between algebraic and numeric expressions. Numeric has no variables. 5 times 3. 6 divided by 4. Those are numeric expressions. Expressions that have variables in them, those are algebraic. An equation is something different. You think of the root word for equation, it's equal. Equation is saying that two things are the same. We're going to deal with that a little later in the week. That's kind of the goal of the entire week here, is to figure out how to solve the equations. Today we're just talking about expressions and how to evaluate them. So that gets to another very important difference. What's the difference between evaluating and solving? Well, evaluating, basically all that means is figuring out what this actually comes out to. Evaluate means substitute the value that you're given in for the variable and do the math. And here, to evaluate this, all we would have to do is know the number of hours, multiply by the $30 you make for each one. So if I work for 2 hours, that's 30 times 2 is 60. If I work for 10 hours, 30 times 10 is 300. So that's evaluate. Solve, again, we're going to focus on this later this week, means to figure out what the variable actually equals. Notice, when I evaluated, I gave you a couple different options for what the variable could be. Solving means figure out what it would take to make the two sides equal. What value of the variable? A couple important things to highlight here. We're looking for a value of the variable itself, and we need the two sides to be the same. Otherwise, we can't use an equal sign there. So for today, we're going to focus on just evaluating. What does that look like? You probably have done this before. Basically, what we have here, we have our expression. Our expression is 6 times the quantity, n plus 2 minus 4. We're going to evaluate this for n equals 5. Okay, well that means just take this 5, plug it in for n, and that's it. So we're going to rewrite this with the 5 plugged in. Very important to show each step of the work here. The reason being, if I just skip and write 6 times 7 minus 4, if I just started right here, or right here, that doesn't really show whoever's reading my work how I relate that back to the original problem. So you need to show this plug-in step right here. Don't forget to do that. Show your work as a way to prove your answer. All right, notice I did the parentheses first because we're following correct order of operation. Then we're going to multiply before we subtract. You get 18 on this. What that means is you subtracted 7 minus 4 and got 3. 3 times 6 is 18. Doesn't work that way. 42 minus 4 38. Do not upset Aunt Sally. Make sure you solve her operations correctly. All right, here's my expression, 3x plus 2y, and I'm going to do that for x equals 3 and y equals 4. So for x, I'm going to plug that in right here, and y is going to go right there. So if this is 3 times 3 plus 2 times 4, 9 plus 8, I will allow you to do that on the same step because they're both multiplication. 9 plus 8 then is 17. That's it. Now, to give you an idea of kind of more what we're going to do in class, this isn't exactly what we're going to do in class. We're going to up it a little bit more than this, actually. This is where the rubber meets the road. This is where we actually use expressions. Here we have an expression, 1.8 times C plus 32. Notice the variable stands for something. The variable here represents the temperature in Celsius. You're watching the Olympics, a lot of times they would bring up the temperature and it would say like 22 degrees Celsius. Well, 22 degrees, that's freezing cold. You're not going to play beach volleyball in 22-degree weather. But in Celsius, that might be a different story if it's 22 degrees Celsius versus Fahrenheit. So what we have here, we have an expression that helps us figure out what the temperature is, what a Celsius temperature is in Fahrenheit. Okay? So what they want to know then, they want to know what the boiling point of water is. If it's 100 degrees Celsius, what is it in Fahrenheit? Some of you probably have this memorized. This is just an example to show how this works. So essentially what they want us to do, they want us to evaluate this for C equals 100. Notice how much highlighting I'm doing here. If you don't have a highlighter, get one. Very, very useful for when you're doing word problems. If you only have one color highlighter, get a couple different colors. Really helps you out here. So all I'm doing, I'm going to take this, plug it in for C. The math is very, very easy. The only difficult thing here is picking out the important stuff. Important information. So this is 1.8 times 100. Notice I did not put an X here. If I put an X there, I'm saying 1.8 variable 100, not 1.8 times 100. X no longer means multiply. I'm going to be picky on that because we need to write what we mean. And if we write X, now that means a variable. It no longer means multiplication like it did back in elementary school. All right, so 1.8 times 100 plus 32. Well, 1.8 times 100, that's 180. Plus 32, going to be 212 degrees Fahrenheit. Don't forget your labels, because otherwise, if I just write 212, I'm not making sense of my problem, am I? If somebody asks me what's the temperature in Fahrenheit, and I say 212, maybe they may be able to make that connection, but if they're a little slow like me, they might need you to give the units to be able to figure out exactly what you're referring to.
So now we're going to switch gears a little bit. We're going to get into something a lot more practical. That's how that's the kind of the whole point of algebra is not that you learn these little tricks and that you plug in and that you solve. The whole point of algebra is that we use it to represent real everyday life. In fact, the name algebra is actually Arabic for the unknown. Al is the, gebra is the unknown. So when we have something we don't know, we use algebra to find it. So that being said, what we always want to do is we want to look for some key words, and you've done this before. Look for keywords that represent the operations that are happening. For instance, here we have in letter A the word product, and then down here we have decreased by, increased by the difference. So there's two in this phrase here. I'd like you to box or highlight or underline these words. 24 decreased by the product. So as you read these different phrases, to write an expression, all you need to do is look at the key word and then determine what's happening between the items that are there. So we have 8 and a number n, but we're looking for the product. Well, product means multiply, so we're going to do 8n, which is the same thing as 8 times n. So you could write 8n, or you could write 8 times n. There's that symbol there. I don't want you to use an x. X's, now that we're talking about algebra, x's are off limits for multiplying. If I see you write an x, I'm going to have you erase it and write the dot there. And x would mean a variable. So if you write 8xn, you're actually doing 8 variable n instead of 8 times n. So be careful there. All right, on this one, letter B, we have actually two options. Decrease by would mean subtraction, right? So the issue, though, is that with subtraction and division, it matters what order these come in. So what we have to figure out is this w minus 9, or is this 9 minus w? Okay. To do that, we need to consider what is the exact order of the phrasing here. It says W is decreased by. So we're doing an action here. We're decreasing, and what are we doing the decreasing to? Well, W is the thing that is being decreased, right? And it's that word by means it's being subtracted by 9. So that tells us we got to get rid of this one. And our correct answer is W minus 9. All right, just buzzing down through here. 3 increased by. Now, increased by would mean plus. Okay, so 3 increased by the difference of P and 5. Difference would mean subtraction. So what I've got to figure out is this 5 minus P or P minus 5. But because there's no real, it doesn't say decreased by or less than or less or there's no real thing to indicate order here. Instead, what I have to do is just go by the order of the letters. So when it says the difference of P and 5, they literally mean that. Subtract P and 5, so P minus 5. Okay, now we're going to increase 3 by this amount. So we're going to do 3 plus, let me move that over there, this amount right here. But I want to make sure I'm increasing by this amount. So to make that happen, if I'm going to increase by whatever P minus 5 is, I'm going to go ahead and lock that in first with parentheses. It might not make a difference because we are going to work left to right, but I don't want to do 3 plus P and then subtract 5. I want to do P minus 5 and then increase 3 by that amount. All right, last one here before we take out an actual word problem. Again, this is moving us toward the correct application here. This is moving us toward those real life scenarios. We still haven't quite got there yet. This is 24 decreased by a product. So we're going to decrease by the product of 6 and Q. So first of all, that's 6Q or 6 times Q because we're multiplying. One of the things I'm going to have you do is kind of brainstorm some of the other things and then check your list with me. So 24 decreased by this product. Well, again, we're decreasing by the product. What's being decreased is 24. So we got to ask, is this 6Q minus 24 or 24 minus 6Q? Well, we're decreasing 24 by this amount. So that means the 24 has to go here. There we go. Okay. That's the basics. Let's take a look at one word problem here, just to kind of give you an idea here. For this, you got to kind of work your way through the paragraph. Okay, there is one key word here, very, very important. It says Jared worked for H hours at a pay rate of $5 each hour. Well, it's telling you right away that the variable is H, and it's supposed to represent the number of hours you work. It says if we're going to determine how much money Jared earned, we have to first know how many hours he worked, right? You probably already know what the operation should be here, but just make sure you box and highlight this keyword each. Each means I'm taking each hour and I'm going to add 5 again and again. Every time he works another hour, I'm going to add $5, right? So if he works 1 hour, that's $5. 2 hours, 5 plus 5 is 10. 3 hours, 5 plus 5 plus 5 is 15. Now, I could continue to do that. That would be pretty hard because I wouldn't know how many H's or how many 5s to add. The easier way to do this is to use repeated addition, which repeated addition is multiplication. So that's 5H would be the expression. Now that's an algebraic expression, and until I know how many hours he works, I really can't go any further than this. But if I knew that he worked 25 hours, well then I'm going back to section 1.1 in the book. I'm just going to take 25 and plug it in for H. So this is 5 times 25. And 5 times 25 would be $125. make sure you have that the labels there.